Hi, this is Rick. We're going to start with Chapter 2, Input, Process, and Output. And if you've heard that before, it's probably because it's pretty basic. But this is how the software engineers actually get started. Now, realize that in the course of this presentation, it's not going to replace your book. It doesn't contain all the details. The book contains a lot more examples that you can look down and study. Also realize that it's best if you follow along in your book, and the page numbers are in the upper right-hand corner of the presentation itself, so you can actually do that. This is not just a passive look on and do it. In fact, you're going to be asked to go do some things in your book halfway through the presentation. These are the topic outlines for the presentation, and you'll notice that they're on page 29. So step by step, you're going to follow along in Chapter 2. So let's start by designing a program. As we know, designing a program actually happens in 3 different parts. The first part is the input. So we need something that we can operate on. Input is the data that the program receives. Then we take that data and we process it. We put it through some steps, we change it, we make it more useful, we actually get some more useful data out of it. The third thing is we have output. And the output is the data that's generated and displayed, usually printed or on the screen. Now, the second part, that process part, actually happens with what are called variables. And we're going to talk a lot about variables in this presentation. So what is the process of designing a program? Well, as it starts on page 30, you'll notice that the first one is to understand and analyze the problem. That goes along with anything in life and anything in programming. Then we want to determine the steps involved in the process. So as we do that, in programming, we're going to use several different specific tools. The first one we're going to use is called a flowchart. And this is what a flowchart looks like. You'll notice that it's a picture and it looks like kind of a graphical representation of the process. The second one is called Sudocode. Now, I've misspelled Sudocode here because that's what I do throughout the program, because I think in English they ought to write it the way it's pronounced. So rather than that pseudo stuff, we just call it Sudocode. That's the way it's pronounced. And so this is Sudocode. And it's not really a programming language. It's kind of a fake language, but it's English that can be understood. And the nice thing about this is we can then make a choice of the language once we see the Sudocode and how complex it is and what it needs as a strength. When we analyze the program, basically we're going to do that in 3 parts. So the first thing we want to do in analyzing the program is analyze the input, what is received. Then there's going to be some kind of process performed on that input. And then the last step, produce that output. It's best if we start with the output, because that then defines what the rest of the program needs to do. We're going to take up an example, and we're going to calculate a player's batting average. If that's what we really want out, and oh, by the way, here's the formula for that. You take the number of hits divided by the times at bat. If we really want that, then what do we need to get that? Well, looks like we just need a couple things, the number of hits and the number of times at bat. So now we have our output and we have our input. Well, we're going to calculate the batting average, and the way we're going to calculate the batting average is by dividing the number of hits by the number of times at bat. Fairly simple. If we're going to design this program, how would we do it if we were a software engineer? Well, the first thing we would do is understand the problem, and we would do that with an IPO chart, and that's what we're going to cover in a few minutes. The next thing we would do is we'd look at the logic of the data flow, and that we would do with a flow chart. Once we've got our IPO chart, we understand the problem. Once we've got our flow chart, we understand the logic, and then we're going to actually design the solution, which means we're going to write it in Sudocode, which is the fake programming language we talked about. And then from that, we'll be able to select the language that we're going to write it in. Then we'll write the program code. And then we'll do what is called compiling. And compiling is actually taking the code that we wrote in English and changing it to machine language. Now, don't forget that that computer only speaks ones and zeros, so we've really got to dumb it down. Once we get that done, we're going to test and debug the program. That's going to take a while. And then the last thing we're going to do is release the program to the users. So let's go through this process step by step. So let's start by saying we're going to understand the problem, and we're going to talk about IPO charts. So what does an IPO chart look like? Well, it's a little box. It says, real simply, input, process, output. And this one, by the way, and most of the ones that you're going to do are going to be created in Microsoft Word, in Excel, or in some kind of text edit program. They don't have to follow this diagrammic form. In other words, they don't have to be a little table, but it's nice if they are. And what goes in these tables are basically the names of the variables or the processes that they're going to do. Now, we always said that we have input, process, output, and we always start with output. So if we're always going to start with output, then let's go ahead and see what we said from our batting average example. We said, okay, we're going to have an output of a variable named num. That's the kind of variable it is. It's a number. And we're going to name that batting average. If we have that as an output, then we need the num variable called hits and a num variable called at bat. We then said the process in the middle was the batting average equals hits divided by at bats. And the process in the middle is actually called the algorithm. The whole thing is actually called an algorithm, but usually the math that does the calculating is called the algorithm. So that's an IPO chart. Back to our designing overview. We said we're going to design the IPO chart, and then we're going to develop the logic. So if we're going to develop the logic, then that's going to be called a flow chart. So what does a flow chart do? Well, basically a flow chart is a diagram that graphically depicts the steps that take place in a program. See what? Well, if you want to see what one looks like, take a look at page 33 with me. Page 33 says that there are certain graphical elements that we can use to depict the process of a program. So an oval is a terminator used at the start and the stop of a program. A parallelogram is used for input and output, and a rectangle is used for a process. So if we were going to put something together, let's just go ahead and do that. We're going to say, okay, here's a program flowchart. Now, if you want to see all those symbols used in flowcharting, then go ahead and turn to page 471, and you can look at them. Take a few minutes now to do what is called a checkpoint. So turn to page 34 and do the checkpoint. And by the way, you want to answer the checkpoint questions and then turn to page 81 and see the answers to make sure you got them right. This is kind of a, did I really understand this kind of thing? Welcome back. I bet you didn't do that, did you? I bet you didn't go out and look at the checkpoint, did you? Come on, go do that. That's the way to be honest with yourself. We're in the process of designing the program. So we said to understand the problem, we did an IPO chart. To develop the logic, we actually did a flow chart, which is a graphical representation. And now we're going to design the solution. And the way we're going to do that is by writing a fake language called Sudocode. It's really just kind of English. Tell me what it does. And that'll help us select the language. And then if we can code the program in that language. And then remember what we said compiling was? Changing it from English to computer language. Ones and zeros. This is what a program looks like written in Sudocode. If you want to know more about Sudocode, see page 473 in your book. Now, one of the things that we actually use a great deal in programming is a thing called a variable. Now, I know you've had variables in math and probably in science. We're going to define them in a very different way here. A variable is a storage spot for data. It's actually a physical location in memory, and that physical location is usually in RAM, which is random access memory. It's analogous to a parking spot. In other words, this is where we would store our car. And you'll notice that it's got confines, it's got lines on either side. And the nice thing about this is it's got a number on it, so the 58 is actually the name of the variable. So we would call this 58, although that's not a very good name, and you'll find that out in a minute. What we want to do then is take a look also at input, output, and variables. And when we do that, input is the keyword that takes the value from the user and puts it into the program. And when we do that, we normally store it in a variable. And what do we say a variable is? It's a physical location in memory. A variable is a physical location in memory. And here's an example of how one works. Take a look at this and make sure you understand it. How do we make those variables? Well, programmers define the variables by telling the computer what kind they are, like a num, and then they make up a name because the storage space has to have a name in it. You're usually one word, no spaces. Generally, the punctuation characters are avoided. Generally, the first character cannot be a number. The name of the variable is something that indicates what is really stored there. So you would call it something like annual pay 2009. We use what is called camel casing, and that's popular for naming convention because it actually tells us and gives us a chance to put words together. So camel case, you'll notice that's the way it's written, lowercase c in the camel and uppercase C for case and every word thereafter. So turn to page 43 and do the checkpoint. Welcome back. How do we assign valuables to variables? How do we get it from the keyboard into the program? Variable assignment does not always have to come from the user input. It can come through an assign statement as well. So we can say set the variable price equal to 20. And so we've done that from the program, and here's an example of how that's done. Once we've got the variable's input, then we can actually do some calculations. And these are performed by math operators. These expressions are usually stored as variables in memory. So we can say set sale, that's the variable name, equal to price, that's a variable name, minus discount, that's a variable name. And this is called that thing from math that you've had before, called those common operators. And here's a listing of them. Remember, this is on page 46 of your book. So how do we actually make sure that the formula calculates what we want? Well, we use a little acronym called Please Excuse My Dear Aunt Sally. In other words, there's an order of operations. Parentheses comes first, then exponent, then multiplication and division as they appear left to right in the equation, and addition and subtraction as they appear left to right in the equation. So give this a little thought and tell me what you come up with. 8 plus 12 is 20 times 2 is 40 minus 4 is, okay, so that would be 36, right? Well, actually, if you do it by the order of operations, which is what the computer's going to do, because it follows this rule as a matter of programming, you're going to actually come up with 28. How'd you do that? Go back and look it over and make sure you can get 28. In fact, why don't you turn to page 57 and answer the checkpoint questions. There are a lot of different data types for variables. So the definition of a variable is it's a named location in memory to store data. Okay? And when we actually create that name and that data spot, that variable, we want to make sure that we understand that there are different kinds. So we can have a number, and there are two kinds of numbers, ints, integers, and floats. Those are numbers with decimal points. And then we have two kinds of characters in there. We have a char, which is just a single character, a Y or an N or something like that, or a string, which is a whole lot more characters. And you'll notice that the character variables are preceded and subseeded by quotes. That means what starts after the quote is actually going to be the character variable, and it stops when you pick up the second set of quotes. We also in here have named constants. In other words, those are things in the program that we actually don't change. So the name constant is a name that represents the value that cannot be changed during the execution of a program. So we actually put them in there, and if a value needs to change, it can only be done by the programmer, not by anything else. So we can say there's a constant called interest rate, and that's going to be 0.06 or 6%. We can say there's also a number called interest rate, and that equals 0.06. When you write a program, it's important to be able to document it so that you can actually take a vacation. If people don't know how you did your process, then you're the only one that can keep that up, at least for a lot of job security, but basically your peers are going to pummel you because they need to be able to maintain it. So you're going to write the program and you're going to pass it off to somebody else. They need to know how to maintain that thing. So there are two kinds of documentation. There's external documentation, which is like a user's manual, which we've all seen, and that's done by a technical writer with pictures, and usually if it's well done, that becomes a real Bible for that particular program. Then you have internal documentation. That's notes from programmer to programmer, and you're going to put them in your particular program. You'll notice that that's actually known as comments, and this is an example of comments or internal documentation. So in summary, designing your first program, we've got input, process, output, and I'll let you read this slide over. To finish up, turn to checkpoint number 4 on page 70 and answer the questions. Don't forget to read Chapter 2 again.